Hey y'all, it's me, Miss B. Today we're talking about how to graph linear equations and write equations of lines. So to start off, let's talk about slope. So slope is the way that the line falls. It's going to be the ratio of the vertical change to the horizontal change. Oh, I forgot the word, horizontal. Okay, so usually we talk about slope as rise over run. So here's the equation for slope. I'm going to use this already given bar as like my fraction bar. So this is going to be delta y, so that means change in y over change in x, which is then y2 minus y1 over x2 minus x1. Now we'll talk about this a little bit, but it doesn't really matter what our y1 and what our y1 x1 is and what our y2 x2 is, as long as they are the same point. So let's go ahead and look at this first example here. If I call this one x1, y1, and this one x2, y2, then I have to stick with which is which. So I'm going to go ahead and write down y2 minus y1, so I've got y2 minus y1 over x2 minus x1. So I've got negative 2 minus negative 3. 4 minus 7 is negative 3, and 2 minus a negative 3 is 1. We always want to simplify that fraction down as low as possible for when we graph. So this is going to be negative 3 is equal to m. So that is what we call our slope is m. Okay, so then for our next one here, we've got 3, 1 and negative 4, 1. I'm actually going to switch it up a little bit. I'm going to call this one x2 and y2, and this one x1 and y1. Okay, so it doesn't matter which one we pick as which one. You could do it the other way. Your math's just going to look a little different, but your answer will be the same. So let's go ahead and do y2 minus y1. So I have 1 minus 1 over x2 minus x1. All right, those parentheses don't mean multiplication. It's just a different way of writing negatives. Subtraction, so we've got 0 over 7. So 0 is equal to m. All right, so 0 is equal to m. Okay. That means we're going to have a slope that is a flat line. Okay, go ahead and do number 3 on your own. So what you should have done was said y2 minus y1 over x2 minus x1. So we get 4 over 0. So this right here is an undefined slope because we cannot divide by 0. It doesn't mean that it can't exist. It just means our slope is going to be a straight up and down line. So I'm actually going to come over here and draw a little diagram. I would suggest you put it in your notes as well. So here. Okay, so I'm gonna write my lines here. So I have 4 different types. So here's my first one. It's going to be a positive slope. That looks like this. So if my slope is positive, it should go up and to the right. If my slope is negative, I just wrote the same thing. It should go down and to the right. If I have a slope of 0, then it's going to look like this. And then if I have a slope that is undefined, like I said before, it's going to be a straight up and down line. Okay, so those are our 4 different types of slope. Okay, so we're going to go ahead and look at these examples here. We're going to find the slope of each line. This slope here, we should notice right away that it's going down and to the right. So this is a negative slope. So our final answer should be negative. I am always going to look at my rise over my run. Rise over run. So our change in x over our change in y. So starting left, going to the right is usually, so from left to right is the best way to find your slope. So starting from the left, right here, I need to go down 1, so that's -1, right 3. So down 1, right 3, which means that my slope, m, is -1/3. So if we're always moving from left to right, we'll always get the slope correct. So it's the same way you read a book. If you go from right to left, that's fine, but you will have to make adjustments to your slope. Okay, this one here, you'll notice that we're going up and to the left, so this is a positive slope. So our answer in the end should be positive. Starting from the left, I'm going to go right 1, so that's 1, and up 3, so that is 3. So we have our rise of 3 over our run of 1, so this slope is equal to 3. And our slope is positive, just like we said at the very beginning. Okay, let's look at slope-intercept form. So a function whose graph is a line is a linear function. And you can represent a linear function with a linear equation. All right, so we can write that out, a bunch of different ways. We could have y equals 3x plus 2. We could have 2x plus 3y equals 4. We could have y minus 3 equals 2 times x minus 4. So those are 3 different ways we could represent a line. Those are all different lines, but they're just 3 different ways of writing them. Okay, so slope-intercept form uses both slope and the y-intercept. This is our most popular line. You probably know the equation. Go ahead and write what the slope is of this. Okay, you should have had y equals mx plus b. It's our most popular line. We talked about it all the time in Algebra 1. Okay, so here we are given in part A, so part A and part B, I'm going to draw a line so we don't get confused. So I've got my m and I've got my y-intercept. All right, so sometimes it gives us our y-intercept as a point. Sometimes it'll say b equals. So here's my form, y equals mx plus b. So I need an m and I need a b. So my m is easy to find, it's just 1/5. My y-intercept is always going to be a point on the y-axis. So the point is always going to be 0, something. So that's the point 0, negative, that's actually 0, positive 3. This is 0, negative 3. So the intercept is negative 3. So b is equal to negative 3. So then we just plug it in. So we have y equals 1/5 x minus 3. All right, easy enough. All right, for this next one here, we have to do a little bit more interpretation. So we need to find M and we need to find B ourselves from the graph. So my M is my slope, so I need to do my rise and my run. So starting from the left, going to the right. So I'm gonna go down 3 and then left 1. Or I'm sorry, right 1. So I'm going -3, 1, which is just -3 is my slope. It is going down to the right, so it is absolutely negative. Then my B is where it intercepts with the y-axis, so it intercepts at 4. So B is equal to 4. Plugging that into the equation, we get y equals -3x plus 4. All right. Sometimes we'll be given an equation in a different form, and so we will need to put it into y-intercept form by getting y by itself. So the key here is that we need to isolate y. Okay, so I'm going to do, I'm actually going to leave this first one for you, and I'm going to do the second one with you since it's a little bit more difficult. So I have 3/4 x on both sides, so I'm going to add 3/4 x to both sides here. I can't combine these like terms because they they're not like terms, they don't both have x. So we've got 1/2 y equals 3/4 x minus 1. Then I have 1/2. To undo 1/2, I divide by 1/2, or I can multiply by 2, and I have to multiply both entire sides by 2. I'm going to do that in a different color so it's a little less confusing. Multiply by 2. So then this just becomes y. 3 times 2 is 6, so 6/4x, and then 1 times 2 is 2. And we do want to simplify that down, so we get y equals 3/2x minus 2. If you are uncomfortable with, reducing fractions, you can always just type it in. So you'd type 6 divided by 4 in your calculator, and you would get 1.5. Then you would do 1.5, and you would hit this little button that says fraction decimal is what that means. And so it goes back and forth, and so it would give you 3/2 as your answer. Okay, so here is what that looks like when you are finished. And we don't want to write a mixed number. Do not write a mixed number, because then our equations get confusing. Okay, go ahead and try this next one on your own. So what you should have done is you should have subtracted 5x from both sides. So we get -4y equals -5x plus 16. Then divided by -4. When you divide by -4, you have to divide everything by -4. So -5 divided by -4 is just going to be 5/4x. We can leave it as a fraction. And then 16 divided by -4 is -4. So that right there is our answer. All right, I'm going to save these examples to do together in class. All right, so now we're going to work on some graphing, and I'm going to write out just some steps because I think people benefit from them. So what we're going to do first is always write in y equals mx plus b form. And then second, you're going to graph it. There's really only 2 steps, but we really need to remember that first one. When we graph, we're first going to graph b, and then we'll graph m. Okay, so I'm going to write my equation down here just so I have it. All right, and I want to solve for y, so I'm going to add 2x to both sides. So we get y equals 2x plus 1. Okay, so there's step 1. Step 2 is graph. So b is this value, the second value, so that's 1. We're going to graph 1 first on our graph. So here is the slope, or I'm sorry, the intercept at 1. It's just the value on the y-axis, so it's always going to be on that middle line. Then m is equal to positive 2 over 1. I always like to write it as our rise over our run. And if it's not as a fraction, then the denominator is 0. Or I'm sorry, the denominator is 1. So our rise is 2 and our run is 1. So I'm going to go up 2 over 1, up 2 over 1. And you can do that as many times as you want to. And then we will just graph that line. So, I didn't do that right. Again, I didn't do it right. Jeez. I'm having trouble today, I guess. There we go. Okay, so here is our line. Okay, easy as that. I want you to go ahead and do this next one on your own. All right, so first you should have found this equation in slope-intercept form. So subtract 4x, get negative 7y equals negative 4x plus 14. Divide by negative 7. Get y equals 4 over 7x minus 2. So in step 2, we're going to graph b and then graph m. So b is equal to negative 2. So we're going to go down 2 on the y-axis. And then m is equal to 4/7. So we're going to graph that by going up 4 and then over 7. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. And then we just draw a line through those 2 points. You can use a straight edge if you want to. Your student IDs work great. Okay, so that is how we graph. Okay, that is all for today.